Good. Thanks. So we'll share those mics if that's okay, gents. Hi, I'm Trent Parado, Public Affairs Officer at NASA headquarters. Welcome to today's NASA social media chat for the Orion Multipurpose Crew Vehicle. We've had a great event this morning here at NASA's Kennedy Space Center in Florida to recognize the arrival of the first spacebound Orion spacecraft, the one right behind me. We're excited to have this opportunity to answer your questions at home about America's next generation spacecraft that will carry astronauts farther into space than ever before. We've had a lot of great questions come in so far this morning on the comment threads of NASA's Facebook and Google Plus pages. For those of you following on Twitter, you can ask your questions of the panelists by using the hashtag #AskNASA, and we'll get to as many as we can over the next 45 minutes. The spacebound Orion, behind me, will launch on Exploration Flight Test 1, an uncrewed mission planned for 2014. This will travel 3,600 miles above the Earth's surface, 15 times farther than the International Space Station's current orbital position. This is farther than any human spacecraft has gone in more than 40 years. This flight will help prove that Orion can survive the enormous speeds and heat generated during a return from deep space. We have a distinguished panel of participants here to answer your questions about the spacecraft, the 2014 EFT-1 flight, and the future missions Orion, the Space Launch System in development, will enable. I'd like to introduce them now. First, we have Mark Geyer. He is NASA's program manager for Orion. Essentially, he's the person managing the huge effort at NASA that's building and delivering the spacecraft that you see behind us and the team that'll turn it into a fully operational spacecraft. Next, we have David Beeman, the NASA Space Launch System spacecraft and payload integration manager. He's part of the team working on America's next heavy lift rocket. It's going to provide an entirely new capability for human exploration beyond low Earth orbit. For more information about SLS, you can get all the facts at nasa.gov/SLS. Next, we have Pepper Phillips, the NASA Ground Systems Development and Operations Program Manager. Ground Systems here at Kennedy is leading the transformation of this launch complex to a next-generation spaceport bustling with government and commercial activity. And next, we have astronaut Rex Walheim. He's the astronaut office's main liaison with the Orion program. In that capacity, he provides input from his unique perspective as an astronaut throughout Orion's design and testing process. He's a veteran of 3 space shuttle flights. This includes being one of the 4 NASA astronauts to fly on the final shuttle mission, STS-135, nearly a year ago. So, we're going to jump right into your questions, and we've monitored quite a few that came in this morning. I'm going to take the moderator's privilege and ask the first one, if that's okay, because I'm guessing it's on your minds at home too, and it's Mark Geyer. Why is your spacecraft green?
I had that same question a few years ago. Basically, it's a coating, it's a primer. You can think of if you had a car or other metal pieces, you like to put a primer on it, protects it against corrosion and other things. It'll be covered, so when we fly you won't see the green. We're actually going to have tiles on the back shield that will be black. Part of that is part of the thermal protection that we use as Orion comes back in. And the heat shield itself on the bottom will be white. So all of that has to do with understanding what how we want the thermal properties to behave, and then what coatings we're certifying for flight.
Okay, all right. So the first question we're going to take from the public comes to us from Facebook, and it's what makes the Orion capsule suited for deep space exploration? Would ever like to take that?
Start. Couple things, because of the long duration that it's going to have, and we have 4 people. 4 people are the mission that we have. So the longer you're out in space, the more stuff you need. Food, water. Also, the crew requires suits and other things. Longer duration will actually require a toilet, those kind of things. So that increases the volume. So the volume is bigger. The longer duration the crew is going to be out because, again, the stuff that they need to survive. Also, long duration missions require, or the missions further from the planet require more propulsion tanks, so forth. So the Delta V we use to get us around drive the size of Orion as well. There's a lot of things that you don't see in the structure that would be in the avionics, the computers, and other things. As you get further and further from Earth, you want your reliability. Quality is much more important because failures and issues a long way from Earth are a lot harder to recover from. So those are the kind of things I think are big drivers for us. Radiation shielding is another one. This structure, of course, is a big part of that. And there are other things we do for the crew when they're a long way from Earth to protect them for that.
Got it.
Rex, did you want to? Okay, okay.
Well, let me go. Let me ask a related question, actually, for Rex, and it's something that I saw on Facebook this morning too. And you described how the spacecraft will function and some of the considerations we need to make. But a more pointed question: how will astronauts be able to maintain muscle mass and bone density aboard Orion? How are we preparing for?
It'll be fairly similar to what we do on in the International Space Station. We'll have resistive devices and then potentially some kind of ergonomic device. And it's very important, and that's one of the most important things we're learning from the space station is how to survive in space, how the human body can withstand 6 months, a year possibly, and even longer. And so what we're learning on space station, we've developed some effective countermeasures, how to stay in shape, how to maintain your muscle mass, and we'll incorporate those lessons into this vehicle.
All right, next question. Any plans to make Orion compatible with the International Space Station docks in case of an emergency need to dock?
Part of our plan is to be potentially a backup in the unlikely case that maybe the commercial crew guys are not able to perform that function. So it turns out a lot of the Orion requirements are the same. We have the capability to dock. We can carry people. We have the propulsion capability to do that. So we would they would need to give us a couple years to change our plans to put some things like a rendezvous and docking sensor on Orion, which of course we have the capability to do. So we can do it, but I think the way you said it is right as a backup, because really it's built for exploration. It's, as we talked about, it's bigger because of exploration, so it's not as an efficient an ISS transport vehicle. But we can be ready as needed, if we need to be called up.
Okay. Direct this question to Pepper and to David. What sorts of challenges, technical, communication, et cetera, essentially, as we look to send astronauts to and from deep space here from Kennedy, how do you have to approach that differently than you've ever done before as you prepare SLS to launch from here, as you prepare ground systems to be able to support SLS? What's different this time around when you're looking at a farther target, like somewhere in deep space?
Okay, well, I think we have some experience in going to the moon, and we're going to take advantage of that. One of the biggest challenges that you have is having good, safe, and reliable access to deep space. You talked about the physical aspects, making sure that the health of the astronauts. You have to have redundancy. You have to make sure that if you put a crew out there, you have the ability to get it back. Part of that is the launch vehicle, and part of that is the spacecraft itself. So, it drives our design time, it drives our test time, and we want to make sure that we have the safest, most reliable system out there.
And for us, for the ground, it's much like our processing is just like we do for shuttle or any of the other spacecraft we've launched from here. Our job is, if there's going to be a failure, let it be on the ground. Reliability is a big deal for these guys. We want to make sure the testing, the checkout, the things that we look at on the ground are complete, satisfy the criteria that the designers designed the vehicles to, and then we're ready to go.
Okay. Next question came in from Twitter. What is the predicted date of an Orion manned space flight? And actually, can you give us a little more detail on it? What it is that we're looking forward to?
Yeah, good. So we have this flight test first in 2014. We have an abort flight test that we're working on the date, probably around the 2017 timeframe. That'll be done out of Florida. Our first big test with SLS will be in 2017. It'll be unmanned because we want to flesh out the systems, the integration with the rocket, unmanned before we actually put people on board. So those have to happen first, and then we have a lot of tests on the ground to qualify, ECLS, displays and controls, other things, seats that are part of launching people. So beyond 17, that date is really driven by the budget. We're working with headquarters on exactly what the budget's going to be. It's a few years out. Today we're projecting probably in the 2021 time frame. I believe we can do better than that, and that's what we're trying to work on, accelerating those dates.
Okay, all right. Let's see, we'll do it for David. Question from Twitter. Your SLS is going to take us to deep space, carry the Orion spacecraft there. How much farther outside Earth's orbit is that? What's your line? Where are you aiming? What's the boundary for you?
Well, obviously, I think the first goal is to go around the moon with the first 2 early missions, and we'd like to have a manned Mars mission. A lot of discussion about going to an asteroid. That's one potential, but I think near term we want to repeat the success we had previously going to the moon. We want to make sure we provide Orion with the test flights that they need to prove the deep space capability, and then really, the planets, the stars are the limit.
So we know space starts about 100 kilometers. Is there a measure when you're talking deep space? Is there a certain kilometer measure that you're using? Say SLS needs to get us this far.
I really don't think that, because I think relatively speaking, that's a whole lot closer than we want to go. When we talk deep space, we're talking Mars, we're talking an asteroid, and I think the dividing line between a low Earth orbit and deep space, I think, is a whole lot closer than we want to get as an agency.
Here's a fairly technical question from Facebook. Will the service module be adapted to carry mission-specific payloads, such as planetary science, Earth observation, or astronomy instruments?
So from the beginning, we designed the service module to have cargo carrying capability with a two-tank configuration. So depending on what propulsion delta V you think you need, we can actually carry quite large payloads. In the 4 full tank configuration, like the one we're sending on our flight tests around the moon, we still have volume that can either be attached to the side of the service module, or actually could be areas that we could extract from the bottom. So we are looking at that very closely, because I think it's extremely important to be able to have payload capability, experiment capability. Since we're going to these far places, those payloads will actually give us a lot of capability to understand the planets.
Just a reminder for those of you watching at home, if you're on Twitter, you can ask your questions of the panelists by using the hashtag AskNASA. If you're on Google Plus and Facebook, just look for the comment thread that we have going and put your question there. We have a team getting us the questions just as quick as you're putting them in. So the next one comes from Twitter, and that's, it could be Mark, could be Rex. It's an interesting one. Why did the shuttle fly a manned first test flight, and why are we planning an uncrewed test of the Orion capsule first?
Depends on the capabilities of the system you're developing. What you'd like to do is, if you have the ability to test something unmanned, it's the safest way to do it. And so with the shuttle, they deemed as it got closer to launch that having the presence of people on board was the best way to do it. They couldn't automate the landing sequence in time to be able to put people on, to be able to do it automated for the first flight. So it took a lot of guts and courage to send those 2 guys, John Young and Bob Crippen, on that first flight in a manned configuration. But if you can test these out unmanned and automated capability first, that's the way you want to go.
Anything to add, Mark? Okay, got it. Okay. What scientific fields will be necessary for deep space human exploration? What do you have to learn now scientifically that's going to enable human travel?
Rex has actually been up there, so why don't you start with that?
Okay, for what kind of field you might want to have on a deep space mission? Well, it's going to be a little bit different. From the low Earth orbit, we were building the space station. And we're operating the space station. You have a wide variety of backgrounds, from engineers to scientists to pilots. You can have the same kind of core background for deep space missions, but you're also going to need a more heavily geology-based field of knowledge or training. And so we're actually looking at that in the astronaut office. We're training our astronauts to be better geologists. We're looking at prototype programs, and we did that in the Apollo program. We're going to have to get back to that, because the really important thing about manned spaceflight is you have curiosity. You have a knowledge base they have when they get there, and they have a curiosity when they get there. They can be trained all about geology and told, okay, this is where we want to look at. But when they look to the side a little bit and see something different, they say, huh, that's odd. Those are where some of your best discoveries come from. So we'll try to have a little broader training in geology and some of the planetary sciences, and I think that'll help us out a lot.
And I think a lot of the technology that we need to send people further in space, we're learning a lot on space station. So the long duration, a great question on the bone mass and other things, which was a huge uncertainty until space station, where we've learned a lot about what exercise equipment can do and help. Radiation is another one. We understand what the environment is like. How can we protect the crew better? What are the real effects? That's another one that I think we're pushing the envelope on. 2 good examples.
So David, how about on the SLS side? And this is a sort of related question from Twitter. What innovations do you have to do on your end to sustain human life as we go out into deep space? How are you designing the launch vehicle with that in mind? What innovations do you need to make?
Okay, and I think there's a couple of areas that we have to cover. You have to have a large enough launch vehicle to send the supplies, to send the spacecraft, and other things that you'll need to be able to sustain that. So we have to build this. We have to build it smart. We have to build a vehicle that will allow us to put the payloads, the cargo, and the spacecraft in space to the location that's desired, and have the ability to provide the supplies for that long-term duration. As I spoke earlier, the most important thing is safety. Safety is paramount. And a lot of times safety not only drives our cost, but drives our mass. We need to do things smart. We need to decide when enough is enough. We need to design something that will meet our needs, but we don't need to try to design the perfect vehicle because we'll never get there. So.
Okay, let's see. This question. I'm going to actually ask this of all four of you. What is the core purpose? This comes from Facebook. What is the core purpose of this exploration for humanity? Why are we doing it? Why are we building? Why are each of you, making the sacrifices you are, building your career around this goal of deep space exploration? Why do we do it?
Well, for me, I think exploration is a desire it's in the human heart. People want to explore. And I think true exploration takes the government. It takes the resources of a government to do true exploration. From the time of Lewis and Clark, when President Jefferson said, we want to send you guys out to do exploration, to find a way to the Pacific Ocean. He didn't say go there and set up some shops and make some money. It was true exploration. We didn't know what we didn't know. And then when he sent them out, we found new kinds of plants, new kinds of animals, and we were better as a country for that. I think the same thing holds true with space exploration. We don't know what we don't know. And when we find those things, when we make those discoveries, we're going to be better off just as a people, but also it's going to have applications that help make our life better.
That's exactly right. I think also when you look at some of the more near-term, or I'd say not too far from Earth discoveries, like going to Mars and looking at whether there's life on Mars. I can't imagine anything more fundamental to our understanding of our life and what happens here on Earth if we were to find and discover life on Mars. So, and having people as a part of that exploration, I think is going to be critical. So I think that's just one example. Also, I think it's important as far as to be a great nation. Great nations lead. They lead on things that are hard to do, like exploration. I think the best example is for those countries that don't have that exploration capability, the time and effort they're spending to get it. I think China is a great example. So I think it's something that, as a great nation, as a leader, we need to keep leading in exploration.
And from an overall country perspective and an agency perspective, if you look, when you try to do something that no one else has done, try to go somewhere no one else has been to, you create an environment where people become innovative. They come up with new ideas, new approaches. It becomes a pull technology where you develop the technology in order to reach your goal, and that technology ends up benefiting mankind. So, the things that came out of the early space race, the things that have come out of the space shuttle program, as well as the International Space Station, I think benefit all mankind.
Oh, I think it's mostly been said, but I think it's human nature to want to discover. Discovery is what humans benefit from, what humans pursue, and learning is part of that discovery process. So for us, it's developing a capability, learning, discovering, and pushing the bounds of what the human race has done to this point.
I think I have another question for all four of you, actually. I think you'd all have different and interesting examples. And this is from Twitter, and it's, can you give examples of which technologies from the Apollo and shuttle are used in Orion? But I actually want to expand that just a little bit. So the legacy, what are you building on that's hardware, that's practically speaking related to Apollo and shuttle, that's actually helping you do your jobs and that you're using to move forward?
So there's a couple of things I would start with is the shape. Okay, you look at the shape of Orion, it's very similar to Apollo. We've done a lot of studies on different shapes, and it turns out this shape is actually very close to the optimum for this kind of deep space and the entries that we're going to do. So I'd say we learned a lot from that and checked it again and found out that those guys got that part right. There's a lot of things we learned about radiation, about the lunar dust, those kind of things that we do take into account when we do our internal systems design, because in the long run, we hope we're going to be going to other bodies and need to be able to accommodate those kind of things. Beyond that, though, the internal stuff, computers, guidance and navigation, and so forth, those are really state-of-the-art. We've taken the latest updates for highly reliable computer systems, networks, and those and accommodated them into Orion. So I look at it as from the outside, cars from the 50s and today look pretty similar. They have 4 wheels, they have a steering wheel, but the insides are fundamentally different, and that's much more like where Orion is today. So the shape is the same because that still makes sense from a physics standpoint, but the internal parts, the part that actually keeps the crew safe and gets them to where they need to go, is state-of-the-art.
And I guess when a lot of times we think more toward hardware technologies when we talk about technology advancements and things that we use today. You know, I think one of the things that we've learned most from our early missions in the past is the technologies and analytical tools. The tools that we use today are so far advanced from where we were, and a lot of that came from the early work that came from the Apollo program and others that allowed us to not only test but predict what the results of the test would be, verify those tests, and use those advanced analytical tools to predict off-nominal events so we could deal with them in the future. So to me, the tools is a real technology advancement.
So I really like this question because we've done a lot of study on the Apollo program and the Mercury program and Gemini programs, and as things have evolved, how they ended up choosing the assets that they used and the processing techniques, much of which have been developed over the years. But fundamentally, like Mark said, with the shape of his spacecraft, ground processing requires the basic capabilities to service, to test, and to launch. Those things we looked at, things like transport mode, things like where you integrate a vehicle, integrating a vehicle vertically versus horizontally. We studied all those items and looked at the best capabilities and ways to do it. Now, sure, you have modern capabilities, launch processing systems, command and control systems. All of those things make what has been done in the past far more integrated and better in today's environment. But fundamentally, we're still the same. We're using a crawler to get out of the VAB and transport it to the pad. Once it gets to the pad, it goes through a basic systems test to make sure it's integrated well with the servicing systems at the pad. So a little blend of the old, blend of the new, but they were pretty smart guys in the Apollo era that came up with this.
Yeah, I think I would just echo that. I think the theme you're hearing here is we take the best of what we had in the past and we add to it today's technologies, and we've done that over and over from the basic design, from having a launch abort system and having the capsule on top of the rocket. That increases safety. We learned that the hard way, and we're going to implement that. How we do operations, how we do spacewalks. We've learned how to do spacewalks over the years, and we know how to do that better and better, how to build spacesuits, and then how to operate in space for long periods of time like we're learning on the space station. We're going to put all that to work to make this program work.
A question that came in from Twitter. Will Orion, as currently envisioned, be able to endure in orbit around Mars for the 3 years required for human surface missions?
Today, the Orion systems, we've designed them to be extensible for 6 months in a quiescent mode. So it could be orbiting around the moon. There was nobody on. If it was unmanned system, the systems could survive for 6 months. What we would have to do once we understand the Mars mission more and the specifics about how long, where we would be going, how long we would be there, we'd have to look at each system and decide what it would take to certify those for longer duration. To find actually a lot of the systems can do that. It helps if we had crew on board. In a Mars mission, I expect that we would, right, in orbit, so they could do maintenance and check those systems out. So that'd be something that we would go look to extend where we started from the 6 months we have today.
Another question from Twitter. Do you think the Orion program will last longer than the shuttle program?
So I believe it will, because I think now we're moving back past Earth orbit. There are so many things for us to do beyond Earth orbit, asteroids, the moon, and onto Mars. Also, this Orion design from the beginning is designed to be flexible to handle all these different missions. So I believe it can adapt, just like there was a lot of adaptation between the early Apollo missions up to Apollo-Soyuz. The shuttle design was adapted quite a bit to then become capable of flying ISS. So I think we're already starting with a very flexible system. So I think it can do so many different missions as America decides where it wants to head, that I believe it can last a very, very long time. And the avionics is easily upgradable as well, so we can add new technology, state-of-the-art computers as needed to keep us in step with the technologies.
Question for Rex, I believe, from Facebook. Some deep space flight missions could require 6 months to a year just to arrive at the destination. How would an astronaut spend his or her days during that year's journey?
That would be a challenge. It really would. You know, the thing about being in space and orbit on the space station for 6 months is that you have the view of the Earth to look back on, and you can see your home, and it's right there. It's going to be a tremendous challenge to take a vehicle like this and go off for potentially a 3-year mission. And it's not going to be long, just a few weeks before the Earth starts receding in the distance, and the Earth is just one of the stars among the many. And I've heard some people say it's going to redefine the meaning of the word loneliness, and it will. But there's explorers out there, the same way we've had explorers in the past that crossed oceans, taken new lives, that have decided that they want to devote their lives to exploration, and they'll do that. It'll be tough, and there'll be times where it'll be a real challenge to figure out mentally how you deal with that. But we'll prepare our people. They'll be excited to be the first people going to someplace like Mars, and I think we'll prepare them well, and they'll be able to handle that voyage.
A question from Twitter, is NASA working on a crew habitat to attach to the Orion crew capsule for long-duration missions?
NASA's looking at a lot of different options of how to extend the stay of the crew, whether it be to an asteroid or onto Mars. So we're in the very early stages of thinking about ways to do that. Orion, of course, is designed from the beginning to do rendezvous and docking with space station or with a lander, and so clearly we could do that with a habitat. So we're early in those discussions.
Okay. I think this may be for you and David. What will be the primary fuel for both Orion and SLS? Is there any way to go faster by using some type of solar sail?
Okay, well, if you look at our early capability, we're basically staying with current technologies that we have. You know, you have the LOX hydrogen engines, you have solid fuels, you have in-space upper stages. And so from that standpoint, we are staying with existing technology, but we're looking to stretch that technology and get more out of it. I think long-term, we will have to have some sustained additional capability. I think our partnering with the science communities and technology development folks is allowing us to move forward anticipating that. So I think some type of, solar cell, some type of, in-space stage that's different than what we have today. We'll have to have something like that in the future.
Yeah, so for Orion, we use, hypergolic propellants. They're efficient. They work great. We have systems that are built to operate with them. They're less expensive, so that's why it's part of the Orion design, and it does the mission that it's supposed to do. But David mentioned, NASA's also looking not only at the HAB, but let's say solar electric, other means to accelerate these larger pieces out to these far durations. Those take a long time to do that, right? They're not very fast, but they're get us to further destinations. So we are looking at ways of accelerating the cargo kind of things, and then you get the crew there faster, because you don't want the crew sitting on those for a very long time. But
got it. This is from Twitter, what are the specifications of the Delta IV Heavy that lead it to having been chosen for the EFT-1 launch?
Things we all started from the objectives. The objectives of this test were really to stress the heat shield, stress the exploration functions of the Orion. So there were really two launch vehicles that exist today. that could get us close to the velocities we need to stress the heat shield. One was Atlas V and the other is Delta IV. The nice thing about the Delta IV is the Orion today could basically sit on top, not require a significant fairing upgrade to go do that. So that's part of what we gave the objectives to Lockheed. They did a search of the potential capabilities of the launch vehicle. So it came down to Delta V and minimizing modifications to both Orion and the launch vehicle.
Let's see, when will we be able to send humans to Mars, and when will we be able to send a human to Jupiter, or presumably around Jupiter?
You want to start?
Well, so first things first, you know, we gotta get humans back beyond low Earth orbit, and that's what we're trying to do with Orion as soon as we can. And then I think the key will be what is the next destination, and how do we get the systems, both technology and funding-wise, to make that happen. So right now there is no specific date for Mars. I think the key thing is to be pushing the envelope, learning more about extended duration, the kind of things that Rex talked about, so that we get those behind us, and so we can move forward onto the Mars trip.
Yeah, and I think this is a methodical program that we're going through. This is just the very first launch, but the important thing, this is Orion 001. You know, if we have the opportunity to look back in the future about where this program went, there's no fixed assets that we're going to lose, like the space shuttle. The space shuttle, eventually we reused them until we could continue using them, but they would eventually reach the end of their lifetime. And the other thing about the space shuttle program is that it eventually, you can fly it, we could have flown it for 10 more years potentially, but we're never going to leave low Earth orbit with it. So with this vehicle, we can go any of these places if we just do a build-up approach, and we can make it to Mars someday. It may take, we're not sure, but hopefully we can be in the Mars vicinity in the 2030s. So I think that is a reasonably attainable goal, but it's going to be a stair-step, slow fashion. It's not going to be easy. It's going to be something we just have to remain committed to, and if we remain committed to as a nation, as a space agency, as a contractor family, I think we can do it.
And I think the long-term evolvable approach to SLS in general allows us that. We start with an early capability, a 70 metric ton capability, with the goal driving toward 130 metric tons. Taking that evolvable approach will allow us to prove the technologies that we develop new for this. It'll allow us to take incremental steps, going to the moon first, then maybe to an asteroid or toward Mars. So I think the evolvability is the real key.
Okay, an engineering question. I think you categorized this from Twitter, and it's a doozy. Is there any practical way to generate artificial gravity on a spaceship or colony?
Well, the only way to do it is to have a spacecraft that is tethered and that rotates, basically. So if you had two spacecraft with a long enough tether, you could rotate them on the way to Mars and you'd have artificial gravity. The only problem is if it's got to be very, very large, because it can be very disoriented if you have a large spin rate. So it is possible. That'd be one way to counteract the zero-G in transit. But I think we're getting pretty good in the space station to find out ways to combat the atrophy you get from zero gravity by using exercise and countermeasures. So I think that won't be necessary, but it is possible it'd be very difficult.
This is an interesting question from Twitter. And maybe Rex can take the first crack at it. What qualities would you look for in the astronauts who will fly on Orion? And would an Olympian astrophysicist even make the cut?
An Olympian astrophysicist? Yeah. Well, yeah, they might. You know, there's a certain baseline technical expertise people need. And there's a lot of people that have that. But then the most important thing is the ability to get along with others and the ability to handle adversity. Even today with our 6-month missions to the space station, we train our astronauts to how to cope with adversity. We train them to develop their coping skills. How do you cope with things when they go wrong? We do things like sending people out into the wilderness for 10-day National Outdoor Leadership School training sessions where we learn about what are these people, how do they react when they're cold and wet and hungry. And you'd be surprised that when you get into those situations, you can learn to develop those coping skills. So we need somebody who has coping skills, because like I said, it's gonna be a tremendous journey to go someplace like Mars. So you need the coping skills, you need the interpersonal relationship skills, somebody who gets along well with just about everybody. And then somebody who has an incredible psychological fortitude to handle something like that, to leave his whole world behind and go someplace new with the hope of making new explorations and not a complete guarantee of ever getting back.
How long, this is from Twitter, how long will final assembly take on the EFT-1 Orion capsule, the one behind us?
What you see here is the primary structure that'll hold the pressure, for example, when we eventually send people out into space. That primary structure took us a few months to put together, but there are a lot of other pieces that are already in production that'll start showing up here at the Cape. So I think the next couple of key things to think about is all the avionics, the computers, the cables, all that kind of stuff will start showing up. We'll actually power it on in the February, March timeframe here, right here in this building, do the integrated testing then. The heat shield shows up a little bit later than that. So by the end of 2013, it'll be totally assembled and ready to be shipped for the launch.
Okay, we have just less than 10 minutes, so keep the great questions coming. Again, if you're on Twitter, hashtag #AskNASA, and if you're on Google Plus or Facebook, just find the comment thread and put your question there, and we'll get to as many as we can before we have to end. Next question looks like it's from Facebook. How many test articles have been constructed and used so far?
Start with the Orion side, and then I know David's got stuff, and Pepper does too. So for Orion, we had Pad Abort 1, which was where we tested out the launch abort system. That was probably the first big test article that had to match the mass properties pretty close of what Orion would look like, because we did a full abort test using the full abort motor and attitude control motor. So that was the big one. We did a ground test article, which is actually also in this building, just a little bit down the way. Did that one, first of all, to get our manufacturing processes figured out, and then we also did a lot of acoustic testing, because during liftoff, the rocket creates a lot of sound energy, as well as if we did an abort, there's a lot of energy from that as well. So you need to test the structure under acoustic load and actually do vibration testing to see how it behaves. So we built a ground test article for that. We've done a few boilerplates, which are basically simple structures that model Orion, that we've dropped at Langley in the pool there to get to calibrate our models. As far as, we've had a lot of then component test articles, like panels of the structure that we've put under load, all sorts of smaller pieces that we've done that to, down to triple E parts that we've tested. So I think if you're talking about the big ones, those are the big ones today. EFT-1's the next one. Of course, you see it behind us. We'll reuse this structure, actually reuse the systems in it to do an ascent abort. Again, like I said, here out of the Cape, we'll put a Peacekeeper first stage underneath it and go do that test here out of Florida. So that's, and then we're on to EM-1, which is in 2017.
From an SLS perspective, there's a lot of test articles we've had so far. You look at just in the J2X development, all of the motors that have been tested, the engines that have been tested down at Stennis. There's been, from a solid standpoint, there's been 3 development motors. Then if you start looking toward our support for EFT-1, we're in the process now of assembling our first test article, which is our Pathfinder article at Marshall Space Flight Center. And then in the near term, we'll be building a structural test article also. As we get into further development from a core vehicle standpoint, we'll have significant test articles with that too. So from an overall SLS standpoint, it's been a significant amount of test articles in support of where we are.
And from a ground perspective, we largely benefit from the flight guys' test articles themselves. So we'll take a boilerplate that Mark developed, and then we'll run our recovery operations tests for his recovery operations that we'll perform. So we get benefit when the SLS guys are building their assets. We take our teams and go out to the respective test sites where they have their test articles at play, so we understand the functionality of the systems and can bring that to bear when we design our systems. So.
The test article we have at JSC, where we actually outfit it with the seats and other systems inside, so we make sure that the crew functions can be done, the crew can put their suits on and off, they can get out in emergency. So that's another test article that has more to do with human factors assessments.
And I've been waiting for this question. I've seen it asked a few different ways, but it's the Beatles or Stones, right? It's why have we returned to a capsule design and not a wing design? What is it about capsule that makes it the right design for deep space moving forward?
Yeah, it really comes down to, again, that entry velocity for us. A wing vehicle can make a lot more sense in low Earth orbit. You're using it to give you more flexibility on where you can land on the Earth's surface. We can get that coming back from the moon. The guidance and navigation algorithms and techniques nowadays are much better. We actually do a skip entry technique that slows us down and allows us to target very closely where we want to go. And a wing system would be much more difficult to implement in the high velocities, and it really would not add any functionality to our system that we need.
And I think I'd ask you, maybe even the whole, all the panelists, what criteria would you find the EFT-1 mission deemed as successful? Successful. What are the success criteria for all of you?
We have a long list of specific data we're looking for on this test. Fundamentally, we're testing the heat shield, so that's the obvious one, and we're actually instrumenting it with hundreds of sensors, which allow us to validate our models that we've done to design the system. So we'll actually get real data that says, look, the heat shield performed as expected, and the environment was what we expected. So that's a big one. We do a lot of, the other key things we're going to test is the guidance and navigation system I mentioned. We're actually going to take control of the capsule. It has to control its attitude during entry to make sure we hit the target point. So that's a key one. Did the GNC system work as planned? We have a lot of separation events. For example, the service module fairings will be jettisoned. The launch abort system will be jettisoned. The crew module will separate from the service module. These are all critical separation events that, again, we model very well. We have tools for. We're going to do some tests on the ground. But you really want to fly it in the flight environment to see that it works, because they're very important to the system. And then we'll do the parachute deployment. Again, we do a lot of drop tests out in California, but we want to do the parachute deploy in the exact environments and the ranges we're going to see on flight. So I would say those are the key objectives. So a lot of stuff. There's a lot of stuff packed into this one flight.
I see only 2 minutes left, so I'm going to have to make. Please.
We're also, as David said, we're working out our interfaces with SLS, so we're going to understand the loads to the upper stage. That's important, and Pepper's guys are actually going to recover the capsule on the West Coast with their nominal plan, so they're going to be exercising those things as well. Those are all key objectives to the flight.
Okay, we're going to do speed round here. There's some really great questions. I want to get to as many as we can. Probably have time for like 2 more. The Orion capsule was built to explore. However, I'm a bit confused as to what capabilities will be without a landing module. Let's speak to that.
Yeah, the Orion is not by itself designed to land on another terrestrial body. It's the part that gets the crew there safely and gets them home. If you actually want to land on another body, you would need a lander. So that's part of an architecture that would have to be developed. So that's not the part of the mission that Orion performs.
Okay. Why is it called Orion? Any special meaning behind the mission name?
Gosh, I'm trying to remember. It's been so long ago we came up with that name. I think fundamentally because it's a part of human history to look to the stars. The Orion constellation is a big part of what people have seen for a long time, and I think correlate with space and our curiosity about what's out there. So.
Okay. Unfortunately, I think that's going to have to do it for today. Thank you all for your time and for participating in this, and thank you all for joining us. If we didn't get to your question, fear not. We'll get to as many as we can on Twitter, Facebook, and Google+. We'll try to answer them over the next couple of days before the holiday. If we still don't get to it, just keep hammering us on Twitter. We try to do as the best job we can to answer all questions that come into us. A reminder, you can find all of NASA's social media accounts, including our various centers, missions, spacecraft, hardware, the tweeting robots, the folks tweeting from space, all of it at www.nasa.gov/connect. For more information about progress being made on the future of American human spaceflight, including Orion, the EFT-1 launch in 2014, the Space Launch System in development, the ground systems development and operations, and the thriving commercial space industry that's enabling NASA to set our sights on deep space destinations, you can visit us on the web at www.nasa.gov/exploration. That'll do it. So goodbye from the Kennedy Space Center, and thanks for being a part of the journey.